The second homework section in 12.2 deals with integration of vector value functions. Let's take number 43. So we want to integrate 2ti plus j plus k. So we integrate with respect to the part. So the integral of 2t is t squared. Well, it's 2t squared divided by 2. We carry the I, because the integral of a vector, the result is still a vector. Plus we integrate 1 times j, that gives us tj. Likewise, for k, we get tk. It's indefinite, so plus some constant of integration. 47. So the integral, the first term, 2t minus 1i plus 4t cubed j plus 3 times t to the 1/2 power k dt. So we integrate. So the first part we get 2t squared divided by t, so that gives us t squared minus t, this is I, plus 4t cubed divided by 4t cubed, we integrate that, we get 4t to the 4th divided by 4, so that gives us t to the 4th j, plus 3 times t to the 1/2 plus 1 is 3/2, and that's divided by 3/2. Okay, then plus some constant, we can clean that up. So this is t squared minus t I plus t to the 4th j plus 2 times t to the 3/2 plus c. Now that's 47. What about 49? Number 49, the integral of secant squared t I plus 1/1 plus t squared j dt. So we integrate the ith component, we integrate secant squared t, and that gives us tangent tan ti And then we integrate 1 over 1 plus t squared. That's tan inverse. So plus tan inverse of t j plus some constant. So that was number 49. Let's take number 54. So here we have definite integrals, integral from 0 to power over 4. Secant t, tan ti, plus tan t j plus 2 sine t cosine t k. All right. So we integrate secant t tangent t. That just gives us directly secant. We know that the derivative of secant is secant tangent, so the integral of secant tangent is secant. The integral of tangent is negative natural log of cosine t, because tangent is understood to be sine over cosine. So if you integrate, we use a u du substitution, let u equal to cosine du is negative sine. So we get a natural log there. And then for the 2 sine t cosine t, we use a u du substitution over here. So let u equal to sine t, du is equal to du is equal to cosine t dt. So for the integral of secant tangent, we just get secant t I. The integral of tangent t is negative natural log of the absolute value of cosine t j. Then over here we use a u du substitution, integrate this guy. This basically becomes the integral of 2 times u du, and that gives us u is sine t, so you integrate u, you get sine square over 2, or u square over 2 times this 2. That just leaves us with sine square t k. And this is all being evaluated from 0 to power over 4. So we now look at the secant. That's the same thing as 1 over cosine t I minus the natural log of the absolute value of cosine t j plus sine squared t k, evaluated from 0 to power over 4. So we plug in cosine to be power over 4. That gives us 1 over the square root of 2. We invert that. This just becomes the square root of 2i minus the natural log of cosine of power over 4 is 1 over the square root of 2 j plus sine of power over 4 is 1 over the square root of 2. To be squared, we just get 1/2. Okay, now minus, we evaluate the terms at 0. Cosine of 0 is 1, so this is I. And then this is minus a minus, so this is plus the natural log of cosine of 0 is 1, so this is the natural log of 1 j, plus sine of 0 is 0 k. So this term is 0, this is 0. So we have left, I'm going to just group the terms, the square root of 2 minus 1 times I, get these two terms together. And then there's only one j term, so this is minus, and if you will, you can make that a plus the natural log of the square root of 2 j. This square root of 2 on the bottom is the same thing as square root of 2 to the negative 1, so negative times a negative, we get positive, and then plus 1/2. Okay. Let's do one more here. Number 56. This is the integral from 0 to 3 of the norm of t I plus t squared j dt. Now let's see if we can interpret what this is. This is the integral from 0 to 3. This norm is understood to be the inner product. So it's the square root of the inner product. So if I take the norm of something, I get the square root of each term to be squared inside. So this is the norm of the vector t comma t squared. So to find the norm of something, you recall that the norm, say for example, of some vector a comma b is said to be the square root of a squared plus b squared. So taking that into consideration, we have this is the integral from 0 to 3 of the square root of t squared plus the square of t squared, t to the 4th dt. And you can simplify that. This is the integral from 0 to 3. Factor out a t squared, take the square root of that t squared, we get t times the square root of 1 plus t squared dt. Now to integrate this, we let u equal to 1 plus t squared. And so du is 2t dt, and that implies that 1/2 du can represent this t dt. So we have 1/2 times the integral from 0 to 3 of u and raised to the 1/2, or the square root of u. So u raised to the 1/2 du. So this gives us, yes, 1/2 times u to the 3/2 all over 3/2. That's being evaluated from 0 to 3 with respect to t. We clean this up. So the 2 goes upstairs. It's canceled out with the 1/2, and so we have in the bottom a 1/3 times u to the 3/2, but u is 1 plus t squared, and that's raised to the 3/2 power. These guys are evaluated from 0 to 3. So we plug in t to equal to 3, so it gives us 1/3. This is 1 plus 3 squared, so that's 1 plus 9, and that's raised to the 3/2 power. Then minus 1/3 times 1 plus 0. So we get 1/3. This is 10 raised to the 3/2 power minus 1/3. We can clean that up. That 10, how come the writing here is just not good? This is 10. Okay. So this is 1/3. The 10 to the 3/2 is the same thing as 10 times the square root of 10 minus 1/3. And so just write it as 1/3 times parentheses 10 times the square root of 10 minus 1. Thank you.